All right, so today we switch gears a little bit and we start to incorporate algebra in with the trigonometric ideas. So, whenever we start talking about trigonometry, what we have to do is we have to present the idea of a unit circle. So, let's start there, okay? So, our goal in this section is to explore properties of the circle of radius 1 centered at the origin. We will learn about terminal points and reference numbers. Okay, so let's start with the definition. I'll zoom in a little bit here. So the unit circle is the circle of radius 1 centered at the origin in the xy plane. The equation for the unit circle is x squared plus y squared equals 1. Okay? So again, it's the circle with radius 1, so you can mark a 1 all around, and there you go. So this would be 1 here, this would be -1, this would be -1, right? Has radius 1, so it's a distance 1 from the origin. Okay? Now, that's our unit circle. We have the equation is x squared plus y squared is 1. So a little bit of background information. Your book doesn't provide this, but I wanted to provide it just for perspective and to help you remember things from high school. If you were introduced or when you were introduced to rays, vectors, all of that idea. So a little bit of background information. Here is an angle. This is the initial side of the angle. This is the angle alpha created. This is the terminal side. This is the vertex, okay? This is going in a counterclockwise rotation, and the angle is positive. This is an angle as well. Notice that it's going in what direction? Clockwise rotation. Good. This is your initial side, and that's your terminal side. The angle beta is a negative angle, okay? Here, you have an angle gamma, which is going in what kind of rotation? A counterclockwise rotation. Good, and it is a positive angle. This is your initial side, that's your terminal side, this is your vertex. Okay, and then you have another angle in the xy plane. This is your initial side lying on the x-axis. Your vertex is at the origin, and this is your terminal side. Notice that theta is what we say, this is your angle, theta. Theta is in standard position, and theta is positive. Here's another angle given in the xy plane. Your initial side lies on the x-axis. Your terminal side lies in which quadrant? 3. Good, and notice that theta here is negative. Theta is negative. What questions do you have? Am I moving too quick? Okay. Sounds like they're having a ball outside. More background information. More background information here. Here's an angle where theta lies in quadrant 2. What side is this? Initial side. The origin is your vertex. Good, and this is your terminal side. You got it. Good. Here, theta lies in quadrant 4. The angle is what? Negative. Good. And then your initial side is on the x-axis. We can talk. And then your terminal side is in quadrant 4. Okay? And notice that here, your angle that's created is theta, and theta is called a quadrantal angle. Okay? Now, here's another one. Your vertex is here. Your terminal side and your initial side are the same. Notice that this gives you one complete revolution. This is a counterclockwise rotation, also 360 degrees, or 2 pi radians, or 2 pi, okay? Here, you have a straight angle, which is 1/2 of a revolution. It's counterclockwise, 180 degrees, or what radians? Pi, very good. Or pi radians. Okay, good. Here you have a right angle. This is your initial side. This is your terminal side. It's a 1/4 of a revolution. It's counterclockwise 90 degrees, or what is it in radians? Pi over 2 radians. So you have pi over 2 for this one. You have pi for this one, or you have 2 pi for that. Okay? So just in the future, whenever I don't write it down, you still write it. If I ask you a question and you respond, make sure you're writing it down, because you'll need to refer to that at some point. Okay? All right. So a definition here. Start at the point 10 on a unit circle. Where's the point 10 at? If I draw a unit circle, where's the point 10? To the right, 1. Here, that's 10. Good. Okay, so start at the point 10 on a unit circle. Walk counterclockwise. Do I go to the left or do I go to the right? Left. Counterclockwise for a distance of t units. The point you end up at is called the terminal point. It's called the terminal point, and is written as P of xy. It's written as P of xy. So for example, if you have the unit circle here, you start at 10 and you walk along, t is greater than 0, and this would be your terminal point, P of xy. So we start here, we go around. In red is just the point where I'm saying we started at 10 and went around on the unit circle, counterclockwise. Okay? So if we're on the unit circle, we start at 10, but then we go clockwise, meaning t is negative here. Notice that your red arrow is going in a different direction. And notice that the terminal point is P of xy is here in quadrant 4. Notice we can move, and it can go, your terminal point can be in either quadrant, but the change of the rotation is different. That's all. What questions do you have? Okay? All right. So let's look at some examples where we're going to find the terminal point on the unit circle. We're going to find the terminal point on the unit circle, determined by each real number t. So here, I've given t is equal to pi over 2. So what's the terminal point here? So we start at 10, 0, 1. Very good. 0, 1. And the way we're writing it is P of 0, 1. But writing 0, 1 is okay. But just staying consistent with the way your book presents it initially, they write P of 0, 1. Okay? You'll see me become a little bit relaxed with that and just write 0, 1 eventually. Okay? Now, here, t is equal to pi. What is our terminal point? Negative 1, 0. Good. Would you like a couple minutes to try the rest? Okay. I'm going to pause this and give you a few minutes to try the rest of them on this page. So we found the terminal points for A and B. Find the terminal points for C, D, E, F, and G. You can discuss this with your neighbors. Online, you can unmute your mics and discuss it with each other. So let's go over the remaining parts. So here, in part C, we have that t is equal to 3 pi over 2. What is the terminal point? Someone who has an answer today. What's the terminal point? Yes? Online? Go ahead, go for it. What'd you get? You got it. Very good. P of 0, comma, negative 1. Very good. So that's the terminal point there, okay? Right, because here, this point is what? What's this point? Now I'm just pointing out random information. This is not the problem. What's this point here? What's the green point? 0, 0, positive 1. This point is what? Negative 1, 0. This point is what? 0, negative 1. And this point is? 1, 0. Good. Okay? So, when we go to part D, what's the terminal point? 1, 0. Very good. For E, someone who has not answered today, what's the terminal point for t equals negative 3 pi? Go ahead. Negative 1, 0. Good. Did you draw it?
Yeah.
Okay, so negative 1, 0, p of negative 1, 0 is the correct answer. So if you draw it, then you have your unit circle, right? And then you're saying negative 3 pi. So you take it, you go around, that's negative pi. This is negative what? 2 pi, and then we go around again. So that here gives us our terminal point. Does that make sense? Okay, good. Now, for part F, you have t is equal to 5 pi over 2. What is your terminal point for 5 pi over 2? Go ahead. 0, negative 1. 0, positive 1. Good, it's 0, positive 1. So that should be p of 0, positive 1. And let's draw it to just make sure we understand why. So notice that whenever we go from 0 to here, that's what? Pi over 2. This is 3 pi over 2, and this is 2 pi, which is the same thing as 4 pi over 2. And then you go up, you go back up, and this here gives you your 5 pi over 2. Okay, good. So you have p of 0, 1. What is your terminal point when t is equal to negative pi? Negative 1, 0. Good. P of negative 1, 0. Or you will see some people write, or your book goes back and forth between the following, where you have p of x, y equals negative 1, 0. Either one. So if you're drawing it, then you start here at 1, and then you're going in the negative direction to negative pi here. Okay? Does that make sense?
Yes.
What questions do you have so far? Okay, all right. So now we're going to go over an example where we want to show that our given points lie on the unit circle. How can we go about showing that a given point lies on the unit circle? Any ideas? If you want it, you can answer it. Any ideas? How can we show that a given point lies on the unit circle? No, we wouldn't want to graph it. We wouldn't want to graph it. Think of it another way, algebraically.
Using equation x squared plus y squared equals 1.
Yes, you do. So use your equation. So you have your equation for a circle in general is x squared plus y squared equals 1. So then we know our x. X is negative 24 over 25. We know our y. That's negative 7 over 25. So we substitute those in, and if, whenever we simplify, we get 1, that means that given point lies on the unit circle. Does that make sense? Okay, so let's write it out. So we would have negative 24 over 25 quantity squared plus negative 7 over 25 quantity squared. And what is 24 squared?
$576.
576, good. 25 squared is?
625.
625, good. We'll be adding to that what?
-7 squared.
Which is?
-49.
No. Quantity, remember? Think of -7 squared like that. That makes a difference. So what's -7 squared? 49, good. So we have plus 49 over 625. And what's 5 to 76? Excuse me. Oh. What is 576 plus 49? 625. So you end up with 625 over 625, which is what? 1, right? I'm saying it's 1, right? Which means, hence, we know that negative 24 over 25, comma, negative 7 over 25 is on the unit circle. That's part A. That's how you verify that. Would you like a couple minutes to try part B?
Sure.
Okay, try part B. All right, how do we start this? You want it? Go for it. Do what?
Squared. Yep.
Square what? Both of them. So tell me what to write.
Square root of 11 over 6 squared
Good,
plus 5 over 6 squared.
good.
That comes out to 11 over 36
Mm-hmm.
plus 25 over 36.
Plus 25 over 36, good.
1.
And that equals 1 because you have 36 over 36. Good. So because that simplifying simplifying x squared plus y squared gave you 1, that means that this given point lies on the unit circle. So hence P of square root of 11 over 6, comma 5 over 6 lies on the unit circle. Very good. Okay, so let's look at example 3. Example 3 says, find the missing coordinate of P using the fact that P lies on the unit circle in the given quadrant. So let's just do a quick refresher to make sure that we're aware of our signs in each quadrant. What are the signs of points in quadrant 1? Positive, positive, good. Signs of points in quadrant 2? Negative, positive, good. Signs of points in quadrant 3? Negative, negative, good. Signs of points in quadrant 4? Positive, negative, good. So now, we've had our quick refresher. Now let's apply all of the information we've learned so far and taking into account what we've recalled. So I'm giving you a point, P, of square root 3 over 2, comma, y, and it is in quadrant 4. How do we find the missing coordinate? If you want it, let me know how to get it. Yes?
Well, we know that the missing coordinate is going to be negative because it's in quadrant 4.
So we know it will be negative, so y will be negative. Because P lies in quadrant 4. Okay. Now what?
You would, use the formula, y squared, x squared plus y squared equals one.
Good.
Plug in the square root of 3/2 for x.
Good. So you will have the square root of 3/2 squared plus
Y squared equals one.
y squared equals 1, and then we go through and solve this for y. Good. So let's do that. So the square root of 3/2 quantity squared gives us what?
3/4.
3/4. Good. So you have 3/4 plus y squared equals 1. So that means y squared is equal to 1 minus 3/4. And what is 1 minus 3/4?
1/4.
1/4. Good. And now we do what to both sides?
Square root.
Good. You take the square root of both sides. So the square root of y squared would then be equal to the square root of 1/4. And that means y would be equal to plus or minus 1/2. That means y would be equal to plus or minus 1/2 because you get plus or minus when you take the square root. However, we stated initially that y has to be negative because p lies in quadrant 4. So in fact, we can say y has to be what?
Negative.
-1/2. Good. So since p is in quadrant 4, y must be -1/2. Okay? There you go. Would you like a couple minutes to do B? Okay, take a couple minutes to do B. So what's the setup?
Square root of 3/2.
No.
I'm sorry. You take, -2/3 squared plus y squared equals 1.
So -2/3, and since this is a negative, let's say the quantity squared, plus y squared equals 1. Now what?
Square root of, what on the other side, so it's -4/9.
Nope.
I mean, 4.
4/9, good. 4/9. So note that you're squaring a negative. When you square a negative, that becomes positive, right? So you have 4/9 plus y squared equals 1. So that means y squared equals 1. Continue. -4/9. Good. And 1 minus 4/9 is what? 5/9. Good. So you get y squared is equal to 5/9. Now we do what to both sides?
Square root.
Take the square root. Good. So you have the square root of y squared equals the square root of 5/9. Now, what does that mean about y?
Take away the exponent.
So go ahead. Tell me what we get.
Y equals positive 5/3.
No? Plus or minus what?
Square root of 5/3.
Square root of 5/3. Good. The square root of 5/3. Good. So remember, so a quick aside. I'm going to move this over a little bit. So an aside here is to note that the square root of 5/9 is the same thing as the square root of 5 over the square root of 9. And that gives us the square root of 5/3. Okay? Technically plus or minus that, right? Technically plus or minus. Okay? But for our problem, we know that the point lies in quadrant 2. So what does that mean? Y has to be positive. Good. So since P is in quadrant 2, that means y is positive. So the point is p of negative 2/3, comma, square root 5/3. What questions do you have? Okay, so be able to do the same thing if you need to identify what your x coordinate is, okay? Now, here on the next page, I give you the unit circle. Now, I'll give it to you sooner than some would typically give it to you, because what is done in this section is you learn about reference numbers, which means you typically just need to know, and this is really all you really need to know, is what happens with quadrant 1, meaning you have, when I say what happens with, meaning you know all of the angles here in quadrant 1, you can determine the other angles and you can determine the coordinates of those other angles, okay? So for pi over 2, you have the point is 0, 1. For pi over 3, you have 1/2 square root 3/2. For pi over 4, you have square root 2/2 and square root 2/2. You will probably remember this as 1 over square root 2, comma 1 over square root 2, but then you can rationalize and get this. And the pi over 6 has coordinates square root 3/2, comma 1/2. Are we okay here? Are you sure?
Yeah.
Okay? All right. Online, are you okay? Okay. All right, good. So what happens with these points is if you go into, for example, you can count off like so: pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6, where's 6 pi over 3?
1, 0.
Good, one here, right? So that way you can find all of these. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 8 pi over 4. So the only things left for us to find are the pi over 6 ones, right?
Mhm.
So you have pi over 6. 2 pi over 6 is the same thing as what? 2 pi over 6 is the same thing as what?
Pi over 3.
Pi over 3, good. So you have pi over 6, 2 pi over 6. Remember, if you need to make a call, feel free to step out in the hallway. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. So notice that you picked up every point here on the unit circle. Okay? The only thing that changes about these coordinates from quadrant 1 to different quadrants, depending on the denominator, is the sign of those. And that you remember from the quadrants we just discussed, the points in the respective quadrants that we discussed. So in quadrant 1, remember you said you have positive, positive. Quadrant 2, you said you have what? Negative, positive. Quadrant 3, negative, negative. And then quadrant 4, positive, negative. Good. Okay? So you will need to understand and memorize this unit circle. Not for your exam. This section is not on your exam on Wednesday. However, you do need to know this for future reference. Okay? So now what we're going to do, notice that these are your angles. If we go from 1, 0 to here, that means this is pi over 3. This is our terminal point. 1/2 square root 3/2. So now, what we're going to do is use this information to find the following terminal points. Find the terminal point determined by each given real number t. If t is equal to negative pi over 4, are we going clockwise or counterclockwise? Clockwise. And where do we stop?
And 7 pi over 4.
At 7 pi over 4, right? So we're going from here to here, which means our terminal point is what? What's our terminal point? I can't hear you.
Root 2 over 2, comma, negative root 2 over 2.
Good.
Is terminal point the same thing as like P?
Yes, it is. Yes, it is. So the question was, is terminal point the same thing as saying P of the coordinates? Yes, it is. Yes, it is. The way your book explains it, yes. You can go back and forth between those. Would you like a couple minutes to try the other two?
Sure.
Go for it. Okay. So for part B, we have T is equal to negative 4 pi over 3. Negative 4 pi over 3 is coterminal with or the same angle as what? Angle. Do we go clockwise or counterclockwise? Clockwise. Where do we stop? Where do we stop?
And 2 pi over 3.
I heard 3 pi over 4 and I heard 2 pi over 3. How many say 3 pi over 4? Raise your hand. How many say 2 pi over 3? Raise your hand. You are correct. It's 2 pi over 3, right? So that means negative 4 pi over 3 is coterminal with 2 pi over 3, which means your terminal point is what here? Good. It's negative 1/2, comma, square root 3 over 2. Okay? You will need to make sure you know all of the angles and the points corresponding to them. You may see a quiz eventually that says fill in this unit circle. Okay? And typically I would give you a quiz without using your calculators for this type of information to make sure you know what they are. Okay? So make sure you know this by next week. Okay? So T is equal to 11 pi over 6. Where are we at? Clockwise or counterclockwise? Counterclockwise, good. And then we go around and we stop here, right? So what's your terminal point? Good. Square root 3 over 2, comma, negative 1/2. What questions do you have? Good. Very good. So you really just need to know what's in quadrant 1, and then you can adjust the points based on what your denominator is and what quadrant they lie in, and just change the signs based on the quadrant. Okay, that's all. Now let's talk about, or let's just make an observation. Move this down. To find a terminal point in any quadrant, we need only know the corresponding terminal point in the first quadrant, right? So this observation says. So let T be a real number. The reference number T bar, it's the notation your book uses. Typically we just say reference number, but because your book uses T bar, I'm going to stay consistent with that, so it's not foreign to you. So the reference number T bar associated with T is the shortest distance along the unit circle between the terminal point determined by T and the x-axis. The shortest distance along the unit circle between the terminal point determined by T and the x-axis. So facts. Some facts that you need to know. 1. To find the reference number t bar, it is helpful to know the quadrant in which the terminal point determined by t lies. 2. If the terminal point lies in quadrant 1 or quadrant 4, where x is positive, we find t bar by moving along the circle to the positive x-axis. Moving on the circle to the positive x-axis. If the terminal point lies in quadrant 2 or 3, where x is negative, we find the reference number by moving along the circle to the negative x-axis. Okay? Now, what we're going to do is we're going to find the reference number for each value of t. We're going to find the reference number for each value of t. Okay? So, I'll move this up so you can still see the information. Find the reference number for the value t is equal to 9 pi. So t equals 9 pi. This is what here? 0. And then this point, I'll use a highlighter. This point is what? Or the laser. That's the point, but what's the angle? You answered my question correctly, so good. 180, or in radians it's pi. Good. This is
2 pi, 3 pi, 4 pi, 5 pi,
7 pi, 8 pi, 9 pi, right? So in order to find the reference angle, we have to take 9 pi, t bar would be equal to 9 pi minus 9 pi, or in other words, 0. That's the reference number. It's the shortest distance. Okay? It's the shortest distance along the unit circle between the terminal point and the x-axis. Okay? Let's look at another example. And you'll have to still refer to your facts. So keep that in mind. Part B, t is equal to negative 5 pi over 4. T is equal to negative 5 pi over 4. Negative 5 pi over 4 is in what quadrant? 2. Good. It's negative, so we're going around like this, right? So we're in quadrant 2. So we're using fact what here?
3.
Good. Using fact 3, we have that this would be negative pi minus negative 5 pi over 4. Okay, right? You go to negative pi, and then you have to subtract 5 pi over 4. Okay? And what that is going to do, that's going to give us the reference angle in quadrant 1 that would allow us to have t. So, negative pi minus a negative gives us what? Positive. So this is the same thing as negative pi plus 5 pi over 4. Negative pi is the same thing as what? If you want to think of it in terms of a fraction, with the denominator of 4. Negative 4 pi over 4. Good. And that needs more room, so I'm going to erase this. So that's negative 4 pi over 4 plus 5 pi over 4. That gives us what? Pi over 4, which makes sense, right? Because the reference angle belongs in quadrant 1. And all we have to do is take the point and move that to the second quadrant to find the actual terminal point. We'll get to examples where we're actually finding the terminal point after we find the reference number. Right now, we're just finding the reference number. Does that make sense? See heads nodding? Okay. So, now, t is equal to 25 pi over 6. T is equal to 25 pi over 6. What do you think the reference angle is going to be? What do you think the reference angle is going to be? 5 pi over 3, you said? How are you getting that?
Well, maybe you take the numerator denominator and divide by 2.
No. That's not how we've been finding the reference angles. You have to be able to provide a logical explanation for that. What quadrant does 25 pi over 6 live in?
1.
Quadrant 1, good. How did you figure out it belonged to quadrant 1?
You could count 5 pi over 6 around the unit circle, or you can see that 25 pi over 6 as 24 pi over 6 plus pi over 6.
Good. So here, notice that this is 0. This is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. So this would give you 0, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and then pi is the same thing as 6 pi over 6. So going from here to here gives you 12 pi over 6, right? Go over another 6, that's what?
18 pi over 6.
18 pi over 6. This is
24 pi over 6.
24 pi over 6, which means we only need to go up another little portion right here to get us to 25 pi over 6. So what is our reference angle going to be?
Pi over 6.
It's going to be pi over 6. Good. So now let's figure out how to write that algebraically. Okay? So we know intuitively that our reference angle will be, so our reference angle we've already figured out is pi over 6. Algebraically, how do we do that? Notice that we have 25 pi over 6 minus 2 pi. Minus 2 pi with a denominator of 6 means this is equal to what? What would you get whenever you take 25 pi over 6 minus 2 pi over 6? Or minus 2 pi?
Pi over 6.
No.
7 pi over 6.
Nope.
Repeat the question.
Yes. What do you get when you have 25 pi over 6 minus 2 pi? What do you get?
13 pi over 6.
Yes, you get 13 pi over 6. So remember, you have to find your common denominator. So that will be 25 pi over 6 minus 12 pi over 6, because 12 pi over 6 is the same thing as 2 pi. We wanted the same denominator. So this gives us 13 pi over 6. This is positive. This is positive. And I'm going to run out of room. Do you have the diagram? Or do you have the unit circle where I explained it there?
Yes.
I'm going to erase it now. Well, it won't let me erase it anymore. It's okay. I'm going to make this smaller. So first it's positive and less than 2 pi. Okay, and coterminal. Coterminal meaning it has the same angle. Or yes, the same angle with, or lies in the same place as 25 pi over 6. But we're not done because we need to have our reference angle is one of the actual angles that's in quadrant 1. So we have pi over 2, pi over 3, pi over 4, pi over 6 or 0 or 2 pi. Okay? So, well, there we go. So we're not done. We have to do a little bit more work. So now we have to take 13 pi over 6 and subtract 2 pi again. And what do we get? We have 13 pi over 6 minus what? Can't hear you. Minus what? 12 pi over 6, good. And what do we get? Pi over 6. And we know to stop there because that is in quadrant 1, right? So pi over 6 is our reference angle since it is in quadrant 1. Okay, so that's our reference angle. Now let's do t equals 4. When t is equal to 4, where would 4 be? In what quadrant? Do we go clockwise or counterclockwise? Counterclockwise, good. So we go counterclockwise. What quadrant would it be in? One? How did you get 1?
Because 4 is also 4 comma 1, which is in quadrant 1, right?
No, we're not talking about the point 4 comma 1. That's different. Now we're just saying our angle is t equals 4. Yes.
Would it be in quadrant 3?
It would be in quadrant 3, right? How did you figure that out?
Because I know pi is equal to 3.14 and 3 pi over 2 is roughly equal to 4.7, so it has to be between those.
It has to be between those. Good. So you have pi is here, it's 3.14. 3 pi over 2 is 4.7 something. And then, so that means that 4 would have to be somewhere in quadrant 3. Well, since we went in the counterclockwise direction, it's in quadrant 3. You can go back and use the fact from there. So you would then have your reference angle, and I can write t bar for this. You can write t bar all along. T bar is your reference angle. T bar is equal to 4 minus pi, because pi is, you want the distance from the x-axis, right? The shortest distance. So it would be 4 minus pi, which would be approximately what? Pi is about 3.14.
It's approximately 1.
Give me the 2, give me out to the hundredths place. 4 minus 3.14 is?
Or 1.86.
Say it again.
1.86.
You saying 1?
1.86.
Nope, not 1 point.
0.86.
0.86, good. 0.86. You get 0.86, good. So that would be your reference number. Okay, so what you want to make sure you do, make sure you go through your homework problems here. Okay, because this takes a lot more thought than the other things that we've been discussing. So make sure you go through that and understand this concept. Now, you can use reference numbers to find terminal points. You can use reference numbers to find terminal points. So to find the terminal point P determined by any value of t, we use the following steps. 1, find the reference number t bar. Find the terminal point Q of AB determined by T bar, okay? And then the terminal point determined by T is the point P plus or minus A, comma, plus or minus B, where the signs are chosen according to the quadrant in which the terminal point lies. Okay, so you find your reference number lives in quadrant 1, then the terminal point that you're looking for will be based on the quadrant that your point lies in. Okay? So, let's go through an example here. Given T is equal to 31 pi over 6, find the reference number for T. Would you like a couple minutes?
Yes, please.
Find the reference number for T. Okay, what are you getting? What's your reference number? You said 5 pi over 4? Nope, it's not 5 pi over 4.
Negative pi over 6.
Negative pi over 6? What did you say?
5 pi over 6.
5 pi over 6? Any others? So let's check. Okay? So, what quadrant? How can we figure out what quadrant 31 pi over 6 lives in? This is just thinking. How can we figure that out? Remember the counting argument we did going around the unit circle. How can we figure out where 31 pi over 6 lives? Yes?
We can count 5 pi revolutions plus an additional pi over 6.
What now?
You can count 5 pi on the unit circle, like go around 5 pi times.
So, here, this would give us
Pi,
pi, which is the same as?
6 pi over 6.
Good. So you'd have, and there's a reason why I'm asking you to translate it. So 6 pi over 6? What is this?
12 pi over 6.
What is this? 18 pi over 6? 24 pi over 6? Be completely accurate. And then this is 30 pi over 6. This is, so we need to go back. That's too big.
Yeah.
So this here was, you said 30 pi over 6, which is the same thing as
5 pi.
5 pi, right? And so 31 pi over 6 is going to be in what quadrant?
The
3, right? Does that make sense? Make sure you're comfortable with the counting, right? Because that's what guides you. So here, notice that we went around a few times and this became 5 pi. So we know that 31 pi over 6 is in quadrant 3, and I didn't write it, but we know it belongs in here, 31 pi over 6. So we go back to 5 pi, and we say that the reference number is going to be 31 pi over 6 minus 5 pi. Right, the shortest distance close to the x-axis. So that's equal to 31 pi over 6 minus 30 pi over 6, and that gives us what?
Pi over 6.
Pi over 6, not negative pi over 6. But good. What questions do you have? Yes?
How did you get the 30 pi over 6?
Because 5 pi is the same thing as 30 pi over 6. Let's try it, let's count again. So here to here is 6 pi over 6,
Right.
which is the same thing as pi.
Did you just multiply it? Because it was.
We simplified it. So here, 6 pi over 6, 12 pi over 6, 18 pi over 6, 24 pi over 6, and then 30 pi over 6. So that's the same thing as 30 pi over 6. 30 divided by 6 is 5, so you get 5 pi. Does that make sense?
Yeah.
Okay. What other questions do you have? So then my question in part B says, what is the terminal point determined by T?
Square root of 3 pi by 2, comma.
No? You want not the point for pi over 6, but you want the point, the terminal point determined by T. You want the terminal point 31 pi over 6. Did you raise your hand?
I was going to.
Go ahead.
Negative square root of 3 over 2, comma, negative 1/2.
Good. Comma negative 1/2. Because we know that 31 pi over 6 lies in quadrant 3. So T is in quadrant 3. So the terminal point P of xy is the point negative square root 3 over 2, comma negative 1/2. So remember, you found your reference number for T. We know that the coordinates for pi over 6 are square root 3 over 2, comma 1/2. But whenever we want the terminal point determined by T, we then take that point, move it to the third quadrant, and then we get the negative negative. Do you need me to explain that again? You got it? Okay, so try this one on your own. Same instructions as example 6, parts A and B, but you have T is equal to negative 41 pi over 4. T is negative 41 pi over 4. So find the reference number for T, and then in part B, give the terminal point determined by T. Okay, so for the try on your own problem, we have T is equal to negative 41 pi over 4, and you have to find the reference number for T. What did you get as your reference number? Not everybody at once.
I got 5 pi over 6.
Is that in quadrant 1?
Quadrant 2.
Right. So you always have to ask yourself, whenever you're looking for your reference number, does it come from quadrant 1? Because your reference numbers come from quadrant 1. It's okay. Did you count? Is that the method you used?
Yes.
Okay, so let's try the counting, okay? So we can figure that part out. It's a little tricky. It's not easy. It takes a second, and it takes a few problems, which is why I put the try your own problem here. Okay, so the fact that it's negative means we need to go in what rotation? Clockwise, okay? So this point here is what? And pay attention. I'll give you time to write. Pay attention. Because if you're visual, you want to see it. And then you can write it. So we start here. This is 0. Okay. Now, 0. We go here. This is what? Careful. We're going in what direction?
Negative.
Negative. So this is negative pi, which is the same thing since we're thinking of denominators of 4. Negative pi would be the same thing as what? Negative 4 pi over 4. Okay, so then we go around. This is what? Negative 8 pi over 4. Good, and then we keep going. You want me to change the color when we go back around?
Yes, please.
Okay, so now we go around. This is what? Right, so this is now negative 12 pi over 4. And then we keep going around. We get back here, this is what? Negative 16 pi over 4, good. Then we pick up from there, we go around, this is what?
Negative 25 over 4.
-20 pi over 4. Then we keep going, this is what?
Negative 24 pi over 4.
-24 pi. Running out of room, let's see. There we go. -25. We didn't say -25, what did we say?
Negative 24.
-24 pi over 4. Then we keep going around. We're gonna run out of colors in a minute. So this becomes what?
Negative 28 pi over 4.
-28 pi over 4. Then we keep going around. This is what?
Negative 32 pi over 4.
-32 pi over 4. We getting close. Now keep going. This is what?
Negative 36 pi over 4.
-36 pi over 4. And then this is what?
-40 pi over 4.
-40 pi over 4. Which means if we go back here, around here, what are we gonna get?
44 pi over 4.
Negative 44 pi over 4, which is what?
Too much.
Too large, right? So we go back. And we know that negative 41 pi over 4 is going to belong to what quadrant? Which one? 4, good. Negative 41 pi over 4 is going to belong to quadrant 4, right? But then, because we want the one closest to the x-axis, the shortest distance, we want the reference angle for that. That's going to be what? Or your reference number comes from quadrant 1. What would that be? It will help you to think in terms of what your possibilities are. What are your possibilities for quadrant 1? Your angles.
Would the reference angle be pi over 4?
Yes, it will. It will be pi over 4. Now, think about how many times we went around. And we can look at our colors. Thankfully, we use colors, so good on your part, right? So the red going around once gave us -2 pi, right? Going around with the blue gave us -4 pi. Green gave us what? Yellow gave us -8 pi, and then the black gave us -10 pi. So our reference number, T bar, would be equal to -10 pi minus, and this is where you use T, minus 41 pi over 4. So that's equal to -10 pi is the same thing with the denominator of 4 is the same thing as -40 pi over 4. And then minus a negative makes it what? Plus 41 pi over 4. That gives us what? 1 pi over 4 or pi over 4. Very good. So that is your reference number. That's how you find your reference number. Now, we did all of that work initially to find out that -41 pi over 4 is in quadrant 4. But notice that, and I'm just going to point out something. Pi over 4 is here, right? And the point corresponding to pi over 4 is what?
Square root 2 over 2, comma, square root 2 over 2.
Good. So this is why we say this is our reference number, because what we're going to do is we're going to take this point and we're going to move that point here. And when we move that point to quadrant 4, what does it become? So in B, we want the terminal point. Determine phi t. What is it?
Square root of two divided by two, negative.
Talk loud. You start to mumble when you start second guessing yourself.
Negative. Square root of two divided by two.
Good. This is your terminal point. You got it. Very good. What questions do you have? Okay, this concludes section 5.1 on the unit circle.